I'm Dave King. I'm a Principal Engineer at NCC. At NCC, we're a world-leading research and innovation organisation that delivers impact for industry.
I'm Tom Gould. I'm the Managing Director for Verda UK. We enable progress through innovative solutions for analytical and processing equipment, and I'm here today to talk about our furnace and oven division, Carbolite, with manufacturing facilities in Germany and in the Peak District. So David, what are CMCs?
So ceramic matrix composites are a really advanced type of material that have been developed in the United States for space exploration, defence and aerospace applications. And they look to combine the mechanical properties of metallics with the fracture-resistant nature of composites, as well as the refractory nature of ceramics. Because of those properties, that allows the materials to be used in really extreme environments where you need to have very high performance at high temperatures and with things potentially like radiation as well. And so yeah, these materials are designed for very extreme applications, and in the UK there's been a big push to have these materials to meet our increasing demands across the aerospace, defence and nuclear sector over the last 10 years or so.
So David, where are CMCs used?
So CMCs are only used in applications where you need to have extreme performance and where the high cost makes sense. So this generally falls in applications such as thermal protection systems for space travel, where there's extreme heating upon re-entry. Also applications such as gas turbine engine components. Gas turbine manufacturers conventionally have things like titanium alloys inside their engines, but by switching to ceramic matrix composites, they can operate at higher temperatures and also with lower weights to give you higher efficiencies. They've also been touted as suitable materials for nuclear applications, so nuclear fusion and nuclear fission. I've been looking at CMCs and introducing them into environments where there's really high temperatures and really high radiation exposure.
So what are the opportunities for CMCs in the UK and globally?
So as I mentioned, CMCs have been under development and are in application in the United States at present. But over the last 5 years, there's been various factors that have affected the demand for these materials in the UK. So there's three main reasons why CMCs are now very important in the UK. So number one, as mentioned before, aerospace engines. To make aerospace engines more efficient, we need lighter materials that can operate at higher temperatures, and CMCs can provide those advantages over metals. Secondly, next generation defence systems. Countries around the world are advancing their systems, allowing their defence capabilities to move faster, be more versatile and basically be uninterceptable. And so the UK needs to respond to those threats around the world. And thirdly, nuclear fusion. So the UK has a big advantage in nuclear energy, where it's been holding the JET experiment in Oxford for the last 25 years looking at plasma physics. And it's looking to continue that advantage by creating a nuclear fusion prototype plant in Nottingham by 2040. And CMCs have been identified as materials that can be used instead of metallics inside a fusion reactor, and that can allow higher operating temperatures and potentially double the efficiency of fusion reactors.
So what would the impact be if we weren't able to develop these materials, and why not just use traditional materials for the same applications?
Well, countries and companies across the world are investing in these materials and have been doing so for a number of years, and this is giving them a competitive edge across a number of sectors from aerospace, energy and defence. And so the UK will fail to innovate essentially to keep up with our competitors across the world, as well as a national security issue. If countries are now developing systems that are going faster, quicker, the UK finds itself in a vulnerable position where it cannot defend itself. And so yeah, there's a number of issues from maintaining high value engineering across sectors as well as national security.
What are some of the obstacles when it comes to widespread deployment of CMCs?
So the biggest challenge at the moment is the cost of these materials. Some of them can be about 50 times the cost of carbon fibre composites, and so you really need to have an application where you need the high performance and the cost makes sense. And so finding that correct fit prevents the widespread adoption. Secondly, the supply chain of these materials in the UK is very limited. A lot of the materials that I mentioned have been developed in the US and are under export controls. So being able to find materials that we can freely use in the UK commercially is a big challenge. And so we've got a challenge at the moment where we need to create our own materials in the UK at the same time as learn how to manufacture with them. And thirdly, creating a supply chain. So there's a big polymer composite supply chain in the UK. But there isn't a ceramic matrix composite supply chain at the moment. And so other SMEs who are involved with other materials are looking at CMCs. What they're looking for is a very clear signal from the end users to say, I want X amount of components by this date. And currently it's not quite clear, and so that's preventing people from investing in exploring these technologies.
Okay, so what particular technology do you see as being key for the development and delivery of CMCs in the UK?
So at NCC we have expertise in polymer composite manufacturing, and so we've been trying to adapt our polymer composite expertise to ceramic matrix composites, and so that involves using things like injection techniques, automation, as well as large presses. By utilising our existing expertise in these fields, we can now move from having small samples of CMCs to having something that's large and scalable enough that we can make prototypes for industry. But to make these prototypes, we need very specialist furnaces that can extract volatile gases as we go through pyrolysis, and that's why we've teamed up with Carbolite to manufacture this one-of-a-kind next-generation furnace that's big enough that we can actually put in prototypes into the furnace and manufacture them for industry.
Is large-scale production of CMCs available now?
Currently, so there's two types of CMCs, with the oxides, which are the lower temperature CMCs that can operate up to about 1,200 degrees C. There is a supply chain starting to develop for these materials, and there are a small number of companies who are able to manufacture prototype components for industry. However, with the higher performance, higher temperature CMCs, the non-oxides, which can operate all the way up to, say, 2,500 degrees C, there is no supply chain for these materials. At the moment, we're at the stage where we're doing materials development and developing the manufacturing processes to scale up from small coupons, like we can do at the moment, to something that's large, complex geometry that's suitable for industry.
So when we're thinking of the furnace, what key factors drove the specification for the furnace?
So we wanted to have a versatile system. We want to have a system that can run multiple types of heat treatments, from pyrolysis to debinding to sintering to crystallization. So whilst we're doing research and development, we're always playing with different processes, and having a versatile furnace to be able to apply those heat treatments was very important to us. Secondly, also the size of the furnace was very important. We want to start making CMCs and taking them from lab scale materials to prototypes for industry. So we need to have a large furnace to be able to put these prototypes into to process them.
What were the factors that made you want to work with Carbolite for this project?
With this being a unique furnace, we wanted to work with somebody who's very collaborative and wants to innovate in the furnace space. We also realised that having a furnace of this complexity and size is a huge undertaking, and so customer service was a big factor in our decision. We wanted to have customer support right from the beginning, from the first purchasing of the furnace to specifying it, all the way through to maintenance and service when the furnace is in use. We've been working with Carbolite for a number of years, and we've had a very good working relationship.
So finally, what part can Verda play as a wider organisation when it comes to supporting CMCs?
So as I mentioned before, a lot of these materials are not available off the shelf. We're going to have to develop these materials within the UK, and that involves material science essentially. And so having access to analytical pieces of equipment so we can engineer these materials so they give them the properties that we need is going to be essential to create the next generation of materials across aerospace, energy and defence.
David, thank you very much for your time today, and good luck with everything in the future.
Cheers, it's been a pleasure.